The kind folks over at Elegoo sent me their Mars 2 3D printer to try out, complete with resin and all the tools that I could possibly need, including these itty bitty side cutters. I love it, it's hilarious. I'm not sure what for, there shouldn't be any flash in these prints, but yeah, you never hurt to have too many side cutters. And oh hey look, face masks. These are actually less effective than the paint respirator that I normally use while mixing resin for kyber crystals, but are far more convenient for just going out. Nobody can understand me in that mask. So, thanks Elegoo. The resin came separately from the printer itself, which, that's smart. That's very smart. Would not want that leaking. Alright, that's enough with the accessories. Now let's get to the printer itself. I started by attaching the rubber footing to the base of the ultraviolet light shield. Sounds like a force field, which was easy enough. I did a quick test fitting. Well, that camera angle's not gonna work. After rearranging my camera setup, I peeled away the excess plastic and calibrated the machine using the very detailed instructions provided. The grammar is a little bit wonky, but all the information is there, and honestly, I was just happy to not have to troubleshoot this process online. The build plate can be loosened or tightened with Allen wrenches, which were also provided. Have plenty of my own, but you know, it's nice that they sent them. An interesting design feature of this printer is that it actually prints upside down in a bath of liquid resin, using ultraviolet light to solidify that resin layer by layer, as opposed to heating up a solid to turn it into a liquid to be extruded and then cooled back into a solid like a filament printer would. I'm interested in that because there are certain shapes that filament printers just can't handle, because after they've printed their layer, they're essentially waving a heating element in close proximity to it, which causes it to melt on the print bed. I've had to cut whole portions of some of my other videos because I was supposed to cut away to a model that failed on the 3D printer. And it looks like the Elegoo will be able to solve that problem for me, because by its nature, it's just not going to have that issue. There's no real heat involved in this. Now that I'm done with my calibration, I'm going to get started printing. Note my safety gear. You don't want to get resin on your skin. It's not like it's acid or anything, but it'll stay there for days. So if you do get it on you, wash it off immediately and thoroughly. I do want to point out, it's about a half an hour later, and if you do run out of resin, because you sort of have to estimate how much you need to put in there, you can pause it and it'll lift right out. You can add more and you're good. You may want to be careful though, if you're doing this during the daylight and it's a sunny day, block all the sunlight. Make sure there's no UV exposure, because you do have to remove the UV shield in order to add more resin. You don't want to fill it to the brim though, because as you can see, the mask is causing the resin level to lower and rise depending. You know, it's that bathtub physicist situation. However, you can see in the back, they've accounted for that and they've put in a maximum resin level indicator in there, so shouldn't be a problem. This UV resin reactive printing technology is something that I became aware of while touring a prop house 5 years ago in Vancouver, Canada, and it blew my mind. I was like, would you steal a replicator from the Starship Enterprise? Captain Picard won't get his Earl Grey tea. He's gonna have to go all the way down to 10 forward. And I never in a million years thought I'd have access to such a futuristic technology. And here we are, life goal accomplished. I do want to take a moment to comment on the physical design of the printer. The digital readout is great. It gives you exact figures for print progress, how far along it is in the print, how much time it has left, and what the layer shape looks like. In addition to just looking aesthetically pleasing, with its red UV blocker casing and simplistic exterior design, it feels sturdy and solidly built. Every other printer I've used shakes violently, which then transitions back into the print, creating more work for me to do afterwards in terms of sanding and cleaning up. The Mars, however, no vibration. Part of that is it's stabilized on 4 adjustable rubber feet, but also it's only moving along one axis instead of 3. And it just feels sturdier than other printers I've used. The fan loudness is really an issue that's specific to YouTubers. It shouldn't matter to anybody else. And frankly, since this uses resin, you really shouldn't be in a confined space with it while it's printing anyway. It's got a filter on it, but there's no way for me to know how effective that is. So you should be far enough away that the sound won't really be an issue. Another benefit of the Elegoo Mars 2 printer is that if your print fails, you don't end up with a glob of wasted material that can't be reused, that then has to be melted and cleaned off of the print head. And you don't have to worry about brittle filament breaking mid-print. On that note, my first attempt failed, probably because I paused the print unnecessarily just to test that function, but equally likely there could have been a power fluctuation from something else on the same circuit. The wiring's really wonky in this building. Don't even get me started. It has no bearing on your circumstances whatsoever. These were the failures. One good thing about this resin printing technique is you don't get that curved surface that some 3D printers, traditional 3D printers do, as they rock back and forth. I don't like just throwing away pieces that could be good greeblies, so let's do something fun with these. I set those aside, reset the printer, and while it went to work, I collected other scrap odds and ends. This time, the printer was a success without the interference of a Jakespeare, so I carefully removed the build plate. Oh no, there's drip! And that's why we don't do that. Almost got it on the flash drive. What are you doing, Jake? I set down some scrap paper to catch any of the stray drops, and boy was that necessary. Good call, In-Cam Jake.
They give you a spatula, but in my mind that's just another tool to clean, so don't break. Super. And that's why they provide a spatula. Could you imagine if I had this open?
I poured the resin back into the bottle. The main advantage of the Elegoo is that your print comes out of the printer without any print lines on it, which erases all that painstaking filling and sanding and filling and sanding over and over, because, you know, I don't like sanding. It's coarse and rough and irritating. However, there is some post-work, and that post-work equates to doing the dishes. Although in reality, you're washing one item. It's not such a big deal. I think I can actually fix this with some super glue. While difficult, it is actually possible to fix the helix rook if you break it. You just have to very gently corkscrew the helixes back together. I did that and then painted those pieces black, very roughly I might add. And I used all the prints, both the successes and the failures, to kit bash together this sci-fi land speeder bike. Okay, thanks for watching. I hope this was helpful for people in the market for 3D printers. So once again, thank you to the folks over at Elegoo. I'm thrilled with your product, and you can find links to their products in the description down below. Happy crafting! See you later.